Okay, last video we were finishing up talking about work, and I have drawn something to help you remember some important concepts about work. Here we have two people. This is me. I'm pushing this crate, and this is you. And so let's say this is me, and this is you. You're standing up on top of the crate. I'm pushing the crate. Now I'm going to make my force vector in yellow, and I am pushing this crate in this direction with the force F. And I continue with a constant force F while the crate undergoes a displacement from some initial position to some final position here, and so I have this displacement. So the question is, how much work is done in moving the crate from this position X initial to this position X final? Well, I'm applying a force to the crate and I'm moving the crate so that the work I do, done by me, is equal to my force that I'm applying, F, times the displacement. But what about you now? What about the force that you are exerting? You're standing on top of the crate, so your weight is applying a force, which I'm putting in green here, F, downward. And that is applied for the whole trip duration also. Now, are you doing any work as this crate moves from the initial position to the final position? Well, I deliberately put you on top of the crate to show that you're just going for a ride. You're not doing any work, are you? I'm doing all this work here with my force F because my force is parallel to and in the same direction as the displacement. So it's simply my force times the displacement. Your force in green is always perpendicular to the displacement. So perpendicular force does no work. Okay, only force that is parallel to the displacement vector is going to do work. Now in mathematics, we have a way of showing that. Suppose now, for example, this occurs here. Let's draw my same crate here. But now, instead of pushing it, I'm going to pull the crate with a rope. So here I am here pulling, this is me, pulling the crate with a rope. And I'm going to exert a force F that's going to manifest itself as tension in this rope. Here's my force vector attached to the crate in this direction. The crate, again, is going to move right along the floor from some initial position to some final position. And the question is, what component of the force is doing the work? Well, I can take this vector, and this gets back to the review that I asked everyone to do with vectors. This vector here has two components. It has a component in this direction and a component upward. If you notice this white vector for this force, it's going up at a little angle here. It can be resolved into two individual components, one to the right, parallel to the floor, and one upward, because obviously the rope is being pulled up. Well, this upward component here is doing absolutely no work whatsoever, because the crate is moving parallel to the floor, and this component here is always perpendicular to the displacement vector, which is parallel in this case to the floor. So the only component that does the work is this green component right here. Mathematically, if you look at this, do a little simple trig, this component is the force, F, which I should have put in white, but you get the idea, times the cosine of that angle. So now the net work done by me is equal to the force F here, which I guess would have been more appropriate to put in white. That's the total force I'm pulling in the tension in the rope, times the cosine of this angle theta right in there. This is the component, that's the component component parallel to displacement, times the displacement, which is this vector here, from this point to here. That's where the crate is being moved. In math, whenever you have something times cosine angle times something else, we refer to this as a dot product. So as in vector form, this is the vector F dot, for dot product, with the, well, I'm going to call it D for displacement vector. D for displacement. Let's call this vector in this direction D. So the dot product in math, work, is the force as a vector, that's why I'm putting the little vector sign here, dot displacement. And that is a scalar, so this whole thing, this vector dot with this vector, is not going to be a vector, but it's just going to be a pure magnitude, because work is always just a magnitude. Work doesn't have a vector quantity associated with it. This is going to be the magnitude of F. Something wrong. Okay, magnitude of F times the magnitude of D, what's going on here, times the cosine of the angle between the two. And that's the concept of work. I'll continue this. I'm going to continue this in the next video, but let me just say a couple more things since we're on this. So work is force times distance, basically, times the cosine of the angle in between the force and the displacement. Okay? And I think with that, I'm going to just take a minute to set up, and we'll continue on the next videotape.